In this video, we will be exploring the following problem. A metal ball with a 3-inch radius sinks to the bottom of a cylindrical tank filled with water, raising the water level by 4 inches. What is the radius of the tank? This is a pretty fun and interesting geometry problem, so I'd recommend that you guys pause the video right now and see if you can work it out yourselves. But let's get on to the solution. Let's start this problem by drawing ourselves two diagrams. First, the state of the tank without the metal ball, and second, the state of the tank after the ball has been dropped in. When the ball is fully immersed in the water level will rise, specifically by 4 inches in this problem. And so we know that this change in height, that is the change in water level from our first figure to our second figure, is equal to 4 inches. And if we add a dashed line to represent the initial water level, it becomes clear that the change in volume from our first figure to our second figure, that is this volume I'm shading in right now, is equal to the volume of the metal ball. Based on this information, we can write the following equation. Delta V, which just represents the change in volume, is equal to the volume of the metal ball. Now the shape that represents our change in volume is a cylinder itself, so its volume can be calculated using the formula pi r squared times h. The metal ball is spherical, so its volume can be calculated using the formula 4/3 pi r cubed. Now the r's on the left and right hand side of our equation are not the same. And to avoid confusion, let's call this r sub s to represent the radius of the shaded region, and the r on this side of the equation r sub mb, the radius of the metal ball. If we start plugging in values we know into the equation, it becomes pi times the radius of the shaded region, which is the thing we ultimately want to find out, squared, times 4, which we determined was the height of the shaded region, is equal to 4/3 pi times 3, which the problem tells us is the radius of the metal ball, cubed. We can cancel out a factor of 3 in the numerator and denominator of the right-hand side of our equation, which leaves us with 4 pi times 3 squared, which is equal to 9. And this is equal to 4 pi times the radius of the shaded region squared. We can cancel out the 4 pi terms on both sides, and we're left with r sub s squared equals 9. To solve, we just take the square root of both sides, and we get the radius of the shaded region is equal to the square root of 9, or 3. We know the radius of the shaded region must be the same as the radius of the tank, so 3 inches is our final answer.